for attending today to Argilla Community Meetup. We are very happy as we have today Louis Guitton, which is a long time community member from Argilla. And yeah, he's an AI solution architect. And today he will be talking about NER models and how he used Argilla for annotating and developing NER models. Yeah, I don't want to take more time from Luis. As always, you can put questions in the Q&A session, and we will take those at the end. And yeah, also for today, we will have also Natalia from Argilla talking at the end about the new SDK. Yeah, Luis, the floor is yours.
Thank you so much, Emmanuel. Yeah, today I have prepared a talk for you about NER models in Argilla. And my name is Louis Guitton. I'm a freelancer from Berlin. Before that, I was doing NLP in media for football. I've given a couple of talks. My latest was about knowledge graphs and LLMs. So in general, I'm just very interested in knowledge graphs, and NER is a part of that, as I'm going to show later. So the agenda for today is first to recap everyone on the NER task itself, then to come back on the latest Argilla NER updates and the workflow that goes with that, and then dive into the crux of this talk, which is what's on the right, which is extracting football club transfers from a stream of news. So we're going to have a look at a fun football news data set, and we're going to extract some entities in Argilla. And I will conclude with some input on an NER roadmap for Argilla with findings that I had while preparing the talk and working on NER with Argilla. So let's start with recapping on the NER task. So as you probably know, NER is not the hottest topic right now. And I've created this meme to exemplify that. And of course, I don't want to point the finger at Argilla. I think it's a wider industry thing. But right now, it's all about LLMs, RLHF, language modeling, question answering, machine translation over tasks. And NER is left on the side. But for me, I certainly find NER very interesting. The definition of NER is that it's identifying predefined categories in a body of text. Predefined bit here is important because now we're moving with latest models. We are moving with a more flexible ontology and being able to identify categories in a text without predefining them. But classically, you have to predefine your categories. NER is part of the wider natural language processing topic. It's the same. It's also called entity extraction sometimes, and it's related to or very close to other topics like span classification, token classification, zero-shot token classification. So in fact, I've put a few links down below of like certain very useful platforms like Papers with Code or Hugging Face. And in fact, depending on which platform you go to, you might not find NER per se. So on Papers with Code, you will find named entity recognition as a task. But on Hugging Face, it's not called like that. You will have to look for token classification and zero-shot token classification. On the right, two pictures from Space's Displacy tool, which was one of the kind of major works that really helped applied NLP practitioners like me back then to work with NER, because you could display on the top, you could see entities extracted from text, so like person, organization, dates, and then on just below, you could see also overlapping spans, like spans as opposed to entities, and in this case, Bank of China, and China being as well location, noted GPE here. And so that's the task we're going to dive into today. What are the industrial applications of NER? First, information extraction, where you turn unstructured data into structured data. It's used a lot by search engines to index the data. Second, and that's where I've worked mainly, automating news aggregation, where you can categorize articles automatically based on the entities that they contain. This enables like things like news recommendation or like newsletters or like users to be able to follow topics, like things like that, features that we're all very used to. And then third application, definitely not the last, social media monitoring, where you can identify entities in posts and comments, you can monitor trends, you can discover new topics. And beyond social media, it's more like monitoring of text streams. So there are companies like Primer in the US that do that for the Department of Defense, where they give you a tool where you can dive into any topics and kind of monitor things, right? And so NER is a central part from all of this. There are more applications. And yeah, if you want to have a look more on the research side, I've listed here a small chronology of NER with links to, like with mentions to papers. So first there were rule-based approaches. I didn't put a date there because probably rule-based approaches to find keywords and entities like arrived as soon as like coding came along. But then NER was formulated as a sequence labeling task more formally, and in 2003 RNNs and LSTMs were used. Later in 2011 and 2016, LSTMs were combined with conditional random fields, CRFs, and this sequence labeling task was the status quo for many years. And then the bulk of the work was more to industrialize this approach. So that's where Spacey came along and made sequence labeling for NER very easy by giving you a very easy to use library with NER models that were pre-trained and things like that. It's only in 2018 with transformers and BERT models that NER was formulated as a span prediction task, where you could use the transformer model to get token level representation and then use that to do a classification. So that's what is called rather span cat, for example, in Spacey. I'll come to that in a sec. And then more recently, since 2020, with the LLMs that appeared, in 2023 now we see the use of generative large language models to do NER with things like prompt NER. And in the last sort of 6 months, 1 year, there's been a few papers that are really innovating there. So with universal NER, then later Gleiner, and then as of 2 or 3 weeks ago, a new NER by a French company called Newmind, which are framing NER as a text generation task and doing like improving the state of the art there. Some future research avenues for NER are things like multimodal NER with images combined with text, with image captions, knowledge graph generation, because it's still automated knowledge graph generation is still an unsolved problem and very interesting. And then lastly, smaller, better, faster NER models with the introduction of the LLM-based. And it's great, you have sometimes better performance, but you also have a huge cost of inference and you're using this huge data to do this one thing. So there's papers on distilling those models to do just NER, or I think that. So there's still quite a few interesting things to do, even though, like I was saying at the top of the talk, it's not the hottest. But yeah, transitioning from the research angle to how would you implement NER in practice in Spacey, I've taken kind of the 4 categories that I outlined here, and I just summarized the APIs that you can have a look at if you're interested. So for rule-based NER, you have matchers and rulers in Spacey, very convenient. For sequence and CRF, you have the seminal NER models from Spacey, which are based on the entity recognizer and the transition-based parser. And then for span prediction, you have the span categorizer, the span cat model. And then for the LLM-based, their latest API, which I think is probably already more than a year old or so, where you have this LLM wrapper with the concept of tasks. And one of the tasks that you can perform with an LLM is the NER task. And so it's called spacey.ner.v3. And there you use like chain of thought prompting with the LLM model inside Spacey to do. So there's quite like a few now, and you can certainly combine those approaches, compare them, and basically use Argilla as well for that to compare those different models. And yeah, we're going to see some examples of that later. In terms of data sets for research data sets, it depends whether or not you're looking at flat NER or nested NER. Flat NER means when a token can only belong to one entity. So classically, you have onto nodes 5 and 2003. For nested NER, where entities can belong to another entity, you have ACE 2005 and Genia. The metrics are span level, precision, recall, and F1 score. And for today, for applied datasets for NER, any dataset can work. News are definitely very interesting because usually they are well written by a journalist or something, so it's maybe also easier to find entities in there and to extract structured data out of there. So I went for this dataset that I found on Kaggle that's from 3 months ago on football news articles. So just as a caveat, I think this dataset was scraped off some publishers, probably without their consent. And yeah, I'm just using that for this sort of teaching purposing, but it's not a commercial usage, but you can certainly imagine that in my role at OneFootball, we had a very similar internal data set. OneFootball was a football news publisher, and we had our own football news stream. And in a sort of practical setting, you would have to build your own data set and then work with that. But for today, we are going to just plug this Kaggle data set in there. So that's for part one. Let's move on to the Argilla NER updates and workflows. So Argilla loves NER now. This is, again, a bit of a joke, but you might have seen that NER has kind of like that Argilla has transitioned from the first API for datasets to now this feedback dataset, which is aiming at encompassing all the tasks. And the span question, the spans were the last task to be migrated to the feedback dataset. And so for a long time, I was waiting for this. But yeah, like if you work on token classification like NER or POS tagging or information extraction task, I hope that you pay attention to the last 3 releases, and shout out to Amelie, Natalia, and the rest of the team. So with V1.26 in March, span question is now part of feedback datasets. With V1.27, overlapping spans were added right after that. So that's really cool for not only nested NER, but also CAT models. And then with the latest release, I think, the V1.28, there were even more span improvements. And yeah, the big news is that now the spans are migrated to feedback dataset, and the feedback dataset now replaces token classification, like you might find in some docs somewhere, like the mention of the old API, the token classification dataset. But now I would strongly advise to just move to the new one, even though not all the features are migrated, and I will come to that. But yeah, it's definitely like super nice now to use, and I will show that. Still, I think I felt sort of a need for an opinionated workflow in Argilla for NER. You've probably seen this diagram in the docs. This diagram is very good. It's really actually, once you know Argilla, that diagram is very useful. But somehow it took me a while to really understand like how I could take my NER task and follow the diagram and make it work. And this comes from the fact that in Argilla, there's many abstractions from the users, the workspaces, the records, the data sets, like all of these things. There's also a lot of quick changes to the code base. And there's a profusion of tutorials on the docs. There's, I think, a stance there of using tutorials as documentation, and some of the tutorials grow out of date. It's natural, especially when you do then breaking API changes and you drop like this text classification, like token classification dataset to now the feedback dataset. You might have a harder time to figure out which tutorial is usable directly or not. So I felt the need for an opinionated way of doing things, and I will present my work in progress suggested dev workflow for this. I've used principle from wider sort of software engineering and data engineering, and I could think of only these 2 for now. And the first one is to keep steps idempotent, meaning you should be able to run your code, your Argilla code, every time without breaking anything and multiple times in a row. And you should keep your steps small and testable. That helped me because some of the tutorials, they look like they are a one big step all together. And in a practical setting, you might do more like small leaps forward in your problem and try to like get new ideas from one week to the next, and your data set is already in place and there's already human labels in there, and you might have a slightly different setup in practice. The second principle is keep it stupid simple. So basically try to split the steps by what they're doing, what they're trying to achieve. So for example, dataset ingestion is different from dataset updates. And that's different from user management, and that's different from model training. While sometimes I see some snippets where you kind of instantiate the data set with already suggestions, for example. And for me, like I try to split that because I don't necessarily know ahead of time what suggestions I want to include in my data set, and I want to be able to iterate in a simpler way those steps. So the suggested workflow is as follows. So first you create a local feedback dataset, of course, and you call the feedback dataset.push to Argilla. And then basically that's the only time where you use a local dataset. For anything else, you call feedback dataset.from Argilla, which gives you a remote feedback dataset back. And then you do things there. That's what I will show in a second. For example, for adding records, you need to create like a records generator that returns an iterator of feedback records. and then you can add those records directly to your remote feedback dataset by using the add records method. For updating the records, whether it's for vectors, suggestions, or responses, you do it depends on your use case. Like some of them have a deeper integration, and there is an integration mode in Argilla where some of the integrations are already provided. So for example, the sentence transformer extractor, I think in 2 lines of code, like it will do everything for you. You don't have to worry about anything. But as soon as you want to do your own thing, you have to create your own method with your logic, and there's no sort of unified signature. Sometimes you have to do updates for suggestions in place, for example. And anyway, so once you've created kind of your records, then you call the remote feedback dataset.update records. So that's the way I wrote my Argilla code. I'm actually really looking forward to discussing this with you guys as well, with the community, and getting inputs. I think like providing this sort of scripted recipes for, let's say, NER is not so straightforward. There's an API called the task templates in Argilla, but there's no task template for the spans yet, and any sort of input there I think is valuable. And so that's to catch you up on Argilla, on the latest news, and on the suggested workflow. And now we can move on to kind of the demo, where we're going to extract football club transfers from news. So on the right there, you see a website called Transfermarkt, which is a big website in Germany and pretty known worldwide from football fans. It's one of the top 25 German websites, and it's essentially just a database. I say just, but it's a database of football transfers. And so you see here a table of players that have an age and a nationality, and they left the club to go to another club, right? And so the motivation for today is like, what if we were rebuilding Transfermarkt automatically by using NER to extract these transfers from a stream of football news and populate that structured database on top. So full disclaimer, I didn't have time to go all the distance. There might be a part 2 later, but that's the motivation for today, and I've outlined the different steps. We'll start the NER project and create the ontology. We'll import some data. We'll annotate some data. We'll filter and find similar records. Then we will add suggestions with a model, and we will correct the model in the UI. And then after that, you have the more kind of advanced steps where you can do weak supervision for better suggestions. You can compute metrics. You can train the model and potentially expose it via an API. And then you can export the model and dataset to Hugging Face. So I've not covered those last steps, but we'll get close to it. So the motivation is the following. We've talked about the different applications of NER, but the interesting thing from my point of view is that whether independently of the domain, whether it's for medical coding or financial news analysis or legal documents parsing, even aerospace requirements engineering, I just found a paper recently that was doing that with the BERT NER model. All of those across those different models, the NER workflows all more or less look the same. They look like this. So first you have a domain-specific corpus of unstructured text. So of course you need to first get your hands on one. Then you use a tool like Argilla to develop an annotated corpus for the NER task. And it can be as small as about 1,000 sentences. Then with those labels, you fine-tune a BERT model on the corpus using something like Spacey. And then you can perform NER with your new model to get your structured data and create a database or create a knowledge graph or an ontology or whatever you want. And so Argilla and data labeling is core to this, and that's why I find this interesting. And so now for the steps 3.2 to 3.6, we're going to move to VS Code. I have Argilla running here with some data sets that, don't worry about them because those are just like demos, quick demos. And we are going to open this notebook. So it's available on GitHub, but it's not the cleanest at the moment because I was a bit short on time. So I will share it later on more widely. But yeah, so we start Argilla and we connect to a localhost, and then we start. So for now, I will just delete my Argilla project called Football News. So again, these two lines are needed for the whole thing to be idempotent. And so here, if I refresh, I just have my demo datasets that start all with NER level something. We're not going to really have a look at them. And now we're going to create our dataset for the football news article transfer NER task. Like I was mentioning before, we create a feedback dataset locally, and then we follow the API of feedback dataset. So we need to create the fields. So in this case, I create one field called text, in which I will put the title and the body of the article. And then just to flex a little bit on what Argilla can do, I created two questions, which is why one of the reasons why I find Argilla also very interesting is that you can do, of course, a span question, and that's the main point of the video 1.26 release. So here we're gonna create an entities field in the document based on the text field, where we are going to label competition, team, player, match, and transfers, and we allow overlapping entities, which came in the 1.27 release. But we're not going to do only that. We're going to also have just a text classification question where we're going to have football types of articles, so coach commentary, transfer news, match report, player profile, etc., etc. And this one is not required, so the human annotator doesn't have to label that, but you can imagine that there might be interplay down the line between some of the entities and some of the categories, some of the topics. For example, a match tag might occur a lot in a match report and things like this. With one data set, you could label multiple things at once. And I find this super cool because it was as easy as. Then in terms of metadata, I'm just showing like the bare minimum here, but you could imagine if you have an internal data set with internal database with a lot of metadata, you could pass a lot of fields. Here in my data set, I just have the link and the source, and then I leave the vectors empty, and the guidelines, I just put something very simple. So if I run this, and then I push to Argilla, this is the last time we see a local dataset. And if I refresh this, I see my football news datasets. It's empty. If I go to the settings, I see my info. I see my field, which is a text field with just text. I'm not using Markdown. And my two questions are the following. I have my entities question with competition, team, player, match, transfer, and then my category with all the different categories. So one thing just quite important to note at this stage is that you have to know ahead of time the ontology that you want to label for, right? So you remember when on one of the very first slides when I was defining NER, I mentioned that classically you needed to predefine the labels. And so that's what's happening here. You need to predefine the 5 labels, and there's no way here to modify the labels. You can reorder them, but you cannot update them. So you would need to just destroy your dataset and create a new one, right? And in practice, it's very much one of the interesting things that happens. Like you might think you start with competition, team, player, match, transfer, but down the line you start annotating, you realize that you missed stadiums or you missed non-player persons, for example. And so there is in practice like a sort of a need for a more agile, let's say, ontology. And some of the newer models with the zero shot, they are very agile in that sense. So that's an interesting thing that we'll park for now. But yeah, I just wanted to draw your attention to this. And then we see the metadata here, and we can delete it. Okay, let's go back to the notebook. So now that we've created the dataset locally, we can import the data. So for importing the data, as I mentioned in my suggested workflow, we need to create a method which is a generator of feedback records. And that generator you can write the logic that you want. In my case, I'm reading my Kaggle datasets locally into a pandas data frame. I'm doing some kind of filtering. I'm not including all the articles in there. And then from there, I'm populating records. I'm iterating over the pandas data frame, and I'm populating record that I'm yielding to create this generator. So that's my logic, and you see here I'm just concatenating the title and content into text. I'm passing some data set, and then I'm leaving everything else empty for now. So responses, suggestions. So that's the stance that I take in my suggested workflow, where I keep things simple, stupid. So here I don't care about responses, suggestions, vectors. I just add the data. If I run this, I will again pull the dataset from Argilla. So I have a remote dataset, and then I'm going to add the records. And here, just for the sake of this demo, I'm just putting a limit of 50 just to go fast, but you could, of course, add more. So now we should refresh and we should see some articles, and we have the articles already, right? And so from there, what I want to show you is, I want to annotate some data, and I will show you how to filter by metadata, and we're going to go through a few cherry-picked cases. For example, this one, I can start annotating with number 2 here. Southampton is a team. Huddersfield Town is a team. Southampton 5-3 against Huddersfield Town is a match. And right away you see overlapping spans. Russell Martins is a coach. So I don't have an entity type for that. Saints is a team. It's a nickname for Southampton. They score 5 second-half goals to preserve long unbeaten, etc., etc. And then you see that classically in media, like the articles are actually quite long. And it's not your typical NER task like in research or in the onto notes dataset where it's only 1 or 2 sentences. Here, I chose to keep the entire article together and not split by paragraph or something, because if you want to enable like use aggregation or use recommendation or all of these features, you need to keep a document level view. And that's why, for example, we have this categorization on the right. So this particular article would be like a match report, probably, then we can submit. And so that's already a match of 2 teams with overlapping spans for you. Then we're going to look for transfer Kylian in here. Yeah, I think that's the one. Yeah, that's the one. So here I'm going to look at Kylian Mbappe. That's a player. We have Michael Arteta says Arsenal. So we have a team here. I have to be in conversation to sign PSG. That's a team, but hints Real Madrid move is likely. So those are teams. And we're definitely talking about transfer here. So I will pick my number 5 transfer and a Real Madrid move, right? That's a transfer. And Arsenal, a move to Arsenal is implied in the title here. There is no span that is easily labeled here. So I'm going to carry on a little bit. Mikel Arteta says East Side Arsenal have to be in conversation to sign PSG for one Kylian Mbappe this summer. So, to some extent, you could highlight this entire thing and say this is a transfer, right? And probably this is either transfer news or coach commentary, but I will say transfer news for the time being. And this is typically like what we are interested in to rebuild transfer marks, because even if it's a rumor or if it's a soft news about a transfer, we could surface that into our database. So I'm going to submit and I'm going to move on to the next example. I'm going to look for 5.3. I've showed you the match report labeling already. I told you about the fact that we can't change because, for example, let's say 5.3, we've seen it with coaches. We've seen coaches pop up a few times and we don't have an entity for them. We also know for scores, for example, this 2.22 might be an interesting entity to also surface depending on the use case. And if I want to now add an entity type called score, I need to restart over. And just one thing I wanted to mention, the old dataset types allowed you to filter by regex using the Elasticsearch syntax that was under the hood. For example, I have this funny scores regex that can extract a group you have here a digit group with either a dash or a 2 in the middle and then another digit group. And that's going to catch scores for you. And so I could, if I was labeling all the match reports in my dataset, I could look for that regex here and then really quickly label all the matches. I could also do it just by looking for 2-2, for example, and then I have 13 examples here, and we see that it's a match report. I can submit real quickly. I go to the next one. This one is maybe not a match report. This one, no, but this one definitely is. So I can really quickly annotate and stay in the flow like that. So that's for annotating data and filtering. Filtering by metadata, and you probably know, but you can go here and filter by source. In my case, I just have one source because I took only 50 articles. All right, so now let's find similar records by vectors. So notice that here, for now, there is no find similar articles here. So in order to enable that feature, I'll do another step here where I import the sentence transformer extractor from the integrations module. And like I was mentioning before, that's one of the modules that's fully deeply integrated with Argilla. So the syntax is actually very easy now. I'm going to just select a fast and small embedding model. I'm creating this sentence transformer extractor object. And then I pull the remote dataset from Argilla. And then I will just call the update dataset function with updating the records and overwriting the records. And this is super fast on 50 articles. And then I refresh this, and suddenly I have a find similar button that's available. And let's look for here similar articles to my Rodri Man City midfielder piece. And I want to look at the top 10 most similar articles, and the most similar here is 77%. And it's talking definitely about Man City. It's not talking about Rodri specifically. So that's cool. Depending on what I'm looking for in my labeling session, that might become very handy. Again, if I do, for example, Man City 2 or Everton, and I am labeling match reports, I want to find similar articles. You see here that it changed, and I have another match report right after. That's not specific to NER, but that's very useful for our case, because we are going to need to label teams, competitions, transfers, matches, and things like that. Okay, let's move on to 3.6 and adding suggestions with a model. We have two questions in our dataset. We have the categories of the article, and we have the spans. And so I've written the code for both. So in this case, if we wanted, let's start with the text classification. I'm not going to run that because it takes a while and we're less interested in this. But you could, if you had already a few labels, you could train a model with setFit in just a few lines, and then use that to add suggestions. But in this case, I'm going to do zero-shot classification, importing a small and fast model. And then I will again pull the remote dataset from Argilla, modify my records, override the suggestions in this case, and then call update records. And this will take something like 5 minutes, so I'm not going to do that. The problem with that is that in my case, the accuracy of those zero-shot classification models were not great. The inference time was super high. And so instead, you would just label a few in the tens of articles and train the classifier with setFit and just do that with that. What I'm going to show is how to add suggestions for NER with a zero-shot NER model, and we're going to use the new state-of-the-art NER model that I mentioned earlier, the new mind model called U0 token, which is on Hugging Face. So the nice thing here is that, and the specific thing to that model, let's say, is that this model is actually a spin on the Gleaner paper. So you can use it just like you would use a Gleaner model. And for Gleaner, there's already a Gleaner Spacie package, which allows you to integrate Gleaner models into a Spacie pipeline. So that's what I'm doing here. I'm loading the Spacie model without the NER component, and then I'm adding the Gleaner Spacie pipe, but with the Gleaner model being the new mind, new NER model. I'm going to run this just so that in the meantime I can tell you the other thing. So you notice that you need to pass here a set of labels, and that's the zero shots component where the model is going to use the list of labels and the embedding representation of those labels to then match it to candidate entities. And so in this case, I pulled the labels directly from my remote dataset. And that's one of the nice things of always pulling the remote dataset. You can work with what you know at that time, and you don't have to re-specify your labels by hand or like by importing them from somewhere or whatever. You already have them inside the remote dataset object by going to the entities question and by accessing the labels field. So that's what I did there. And then here we need to actually compute the suggestions and then push them to Argilla. So this is where you have to write your own method with your own logic. So for this, I'm pulling all the records from the remote data sets, and then I'm looping through them. And I parse them with the NLP model that contains the new NER model. And then I went the extra mile to type like here this record suggestion, because you have to be aware of the types that the library is using in the hood in order to write this method correctly. This record.suggestion can be either a tuple or a list actually. And then you can either, like in some of the docs, in some of the tutorials, you're overwriting the suggestions a bit like I did before, where you just say the suggestions are equal to a list of your suggestions. But in my case, because I have two questions, I have the text classification question and then I have the NER question. Here I'm doing zero shot only on the entities, not on the text classification. So I don't want to overwrite the suggestions that probably were that could have been populated by another model that maybe even ran for super long. So there might be like costs associated to that. So instead here I'm appending to the tuple a new suggestion for the question entities. And the caveat here as well is that I'm assuming that there was no previous suggestion for that entities question, because you are allowed to only, there's validation that runs in Argilla, and you're allowed to only one suggestion per question type. And so here, if I already had added a suggestion and I'm just appending without doing more logic, this would break when I'm trying to update the records. But this is just to show the happy path and to show you how it looks. So you pass the records, and so for each record you build an array of entities, and the entities, they need to have the span value schema. And so I pass the entities from Specie model, from the Specie API in doc.ends, and then I populate the object like we want it to be populated. I have to nice here just because new NER requires the labels to be lowercase here, so I had to lowercase them when I passed the candidate labels. So then the Specie model will give you the lowercase models, but Argilla expects the title case models, the title case labels. So again, if you don't title case them, and because the ontology is fixed in a task on Argilla, then it would fail. So I have to capitalize them again. And then I call update records. So this will take just a few more seconds to run. And then we should have all of our entities in the UI. So we are going to see that in a second. And from there, I'm going to label a bit more data, because just to recap on where we were, we've added suggestions to the model. We will see those suggestions pop up. We can then correct them if we want. One thing I wanted to mention as well on the previous point, on the metadata point, I showed just a link and the source in the metadata field, but you could add even more metadata there's an integration in Argilla called test descriptives, where it adds even more metadata, or you can pull metadata from somewhere else and use that to filter. And I'm just waiting for this to be done. In the meantime, I'm just going to carry on with the step 3.7. So you will see in a second that the suggestions are very useful, but they're not perfect. The problem is, like, you will see them all over the place. And the goal here is to minimize human annotation time. So you want good suggestions and you want accurate suggestions. But for an NER task, the actual accuracy, meaning precision or recall, feels very different to the other tasks. Because if you have a very verbose model with great recall, it's going to label everything as an entity, and then you're going to have to correct all those false positives as an annotator. It's going to take ages. And as you've seen, one document in practice can be very long with many sentences. So you're going to have to label like a lot of entities. And yeah, there's a balance here to strike, of course. And so there's three main strategies to improve: trying a better model, doing active learning, or doing weak supervision. And like I briefly mentioned in Argilla, there's something I call this single agent suggestion constraint, where you can only have one suggestion per question. And that's actually pretty good. I'll touch on that here. But so how do we do then to go around that? Let's say you have 5 NER models that you want to try out, and you want to have a look at their suggestions and use human annotation to compute some metrics on how good those models are. I thought of these 3 options. So option 1 could be you add multiple copies of each record with an ID in the metadata, and you add a different suggestion for each record, for each model. But it does mean that each record is going to be duplicated for the amount of models you have. The option 2 is that you could just keep one record like you had before, but then you would use the users API to trick Argilla basically, and then you would create one robo annotator per model and let them annotate using the different NER models. And then you look at them like bots, basically bot users in Argilla, and you could compute agreement matrix maybe. The option 3 would be to work out a way to allow for multiple suggestions with overlapping spans, but then how do you know which suggestion comes from which model, and how do you make sure that you don't create more annotator work? Because each model is going to add overlapping entities, and if they're wrong, the annotator has to remove all of them. So it's definitely tricky. So then that's where we're going to move on to the weak supervision. But before, I'm just going to check. Yeah, we are done here. So I'm going to refresh this. And you see now the suggested entities that showed up. And teams are working well. But again, like the matches, probably we need to assist the model in labeling a little bit with overlapping entities. Diego Yota, Luis Diaz, all of those are players. They score to send Reds. It's a team top of Premier League. That's a competition. That's perfect, right? So I'm not going to look in details, but here you see more or less that we've just a zero-shot model, which is pretty incredible because it has no clue what my thing is here. It has no clue whether Diogo Jota should be a coach or a player, right? But still, like, it labels as players. And of course, as I say that, I see here that Jurgen Klopp is labeled as a player, so I would remove that and keep in mind that I need another person entity type for the model to figure out that it's another person, that it's not a player, things like that. But yeah, certainly for this demo, it works pretty well. And so jumping back into like the motivation for better suggestions, we've seen like just briefly that they're not perfect. And so you would need to work inside the framework of Argilla with just one single suggestion model, and you want to have the best model that you can, right? And so to do that's where you can use weak supervision. You can create different annotator functions to generate the candidate entities with, for example, regex, keywords, and syntactic trees, dictionary-based fuzzy matching with, for example, Wikidata. You can use entity linking against knowledge base like DBpedia. You can use pre-train your model, NER models like new NER that we just used. And once you've done all of that, you need to aggregate those weak signals together. And there are 3 ways to do it. Either you do the union set, where anything that was tagged is by one of the candidate models is a final entity, but this will cause problems as well, because you need to decide on an order or like a priority for those to not have overwrites of entities. You will have low precision and very high recall because a lot of things will be tagged as entities, and this will lead to annotator fatigue as well. The second way is to do majority voting, where predictions are the majority vote of the contributing model. So this is the same as ensemble learning in like majority ensemble learning in sklearn, for example. And then the last one is meta learning or ensemble learning, where you train a new classifier, a separate model, and you train it in a supervised manner on the output of the contributing models and some labels, and then you use that sort of meta model to do the final NER suggestion. And so this I have in the notebook. I wrote a lot of that. I wrote annotators with regex for scores and formation. I'm not going to dive in detail because I didn't have time to finish, but that's maybe for part 2. I wrote an annotator that uses keywords for matches and the syntactic tree, and it's able to label matches. I've written an annotator that queries Wikidata in SparkQL to find, in Sparkle, to find competitions teams, to build like a get the tier from that, a dictionary from that, and then to do basically rule-based matching in there. Although you see that it's not perfect because it doesn't find Ligue 1 here, but it finds Premier League. So here the same with teams. I've added one annotator with the new NER model. And then once you have all those, and I've also added one annotator with DBpedia again. Then once you have all of those, you can combine them in what's called combine annotator, and then you use that to aggregate the weak signals, and for aggregation, I tried the generative model, and I was able to train it, but the results were not great. But zooming back and going back to this, I think, and just closing in one more slide. It's pretty incredible now that all of this is abstracted away in tools like Argilla, like Squeak for weak supervision, in tools like transformers and datasets for the models and for the datasets and things, because all of that is what you would have had to do like a few years back by hand, by creating custom spacey pipelines and like doing a lot of the work by hand. But that's how you get like better NER models. And if your NER model is at sort of the core of your downstream features, you need like a better NER model. So what's next for Argilla? I'm just going to give my 2 cents here, and that's my final slide. But yeah, I've noticed that like the confidence score for span suggestion doesn't seem to be used like for label suggestions. There might be some use cases, or maybe it was just me, but like when you answer, or like when you submit a record, I don't think you still see the suggestions, but there were some cases where a submitted record, I wanted to unsubmit it and put it back in pending. I forget why, but I couldn't find the button for that, whereas there's UI buttons for the 3 other steps. There's no task template yet for span question, which means you have to do the manual thing that I showed. But yeah, those are small things. Then there is feature parity for span question with the other types of questions. So the annotator and command metrics are not migrated to span question, and it's natural because the metrics are harder to compute. You need to pull all the entities and then do a set maths, let's say, or set metrics to compute the metrics. Spacey has a nice score abstraction there that you could use to compute the metrics, but it's definitely a bit of work. Then there's the feature parity for the feedback dataset with the token classification dataset, where active learning is not supported anymore, but you can certainly train your model outside the UI with SetFit. Weak supervision is not supported via the weak supervision module in Argilla, but you can certainly do what I was showing with Squeak outside. And monitoring with the Flask middleware, I think, is not supported. I think for the feedback dataset, I would have to double check on that because I've not used it myself. But it's definitely like a super cool feature, I think, from Argilla to have this other feature down the MLOps lifecycle. And so moving to feedback dataset, ideally you wouldn't want to really lose that. And yeah, the last point is more like a wider discussion, I think, where I think the process of labeling NER is often iterative, and also building cages and things like that. So we often have to evolve our ontology as we progress. You've seen an example here with the coaches or with scores and things like that. And so at the moment in Argilla, you set the labels as input and the suggestions are validated against it. Can we add suggestions outside the labels? Because maybe sometimes that could be useful. Or could we add delete merge labels while annotating? So I've seen, for example, that the tool NewMind from NewMind, the company that released the paper New NER, they have this feature where you can combine merge labels together down the line after you've annotated, or you can delete labels and change your ontology as you go. So that's just as a reference to leave it there, but I find the feature amazing right now in Argilla. I think you can do so much, and I hope I inspired you to have a look at NER, maybe play with a data set of yours on football or on something else, and then let me know if you have any questions on the things that I've showed.
Thank you so much, Luis, for the presentation. It was very complete, and I think it's the best resource right now for getting started with NER in Argilla. So yeah, thank you so much. It is very valuable. We have a few questions that we will answer. The first one is not related to NER, and I don't know if you have experience with AWS, but how can you integrate Argilla with an MLOps pipeline in AWS? I guess he's referring to a SageMaker pipeline.
Yeah. So there's kind of 2 sides of the question. The first one is, are you talking about, I'll assume like both sides. First, if you're talking about deploying Argilla on AWS, there's a bits of the docs on Argilla on how to deploy on different cloud providers your Argilla instance. If you're working, for example, in EKS and Kubernetes cluster within AWS, you can deploy Argilla there. It's definitely like a little bit of work because you have the different moving pieces from Argilla with Elasticsearch and Fast API server and stuff. So you can integrate that with the rest of your services in AWS. And the second part of the question is, what if you're doing NLP with AWS, say Comprehend or the Bedrock models? And then there, like you just, it depends how you're calling your models, but you're probably using some kind of Python SDK to call your AWS language models. And the Argilla is fully scriptable in Python. So within your script, let's say you need to use Comprehend to compute suggestions in your NER task. You could call Comprehend from Python from the recipes that I was showing, and just instead of using Spacey, use your AWS model there. So that's how I understand the question.
Yeah, just to complete the question, I recently worked also on a pipeline that retrieve data from Argilla, and what I did is, to have code and then use this to create a step in the SageMaker pipeline that pull the data. And if it's useful too, the people from CNML, which is a framework that allows to build data strat many cloud providers. They have recently integrated Argilla and will be releasing in the next release of CNML. I think it is the 0.58. So you can also try using CNML to build your SageMaker pipeline, because CNML is compatible with SageMaker. So if that helps. The next one, how would you create a recommender system through a NER approach?
Yeah, that's a great question. So you use it as an information retrieval piece. So you use NER to tag articles with the entities, let's say. And then assuming that you have, for recommender system, you need a data set of interactions between users and items. So let's say your items are your articles, and then you have users, and then you have the interactions. Now, by including NER, let's say you have this graph between articles and items. Now with NER, you're introducing another level of the graph, which are the tags or the entities that belonged to the article. And so suddenly your interactions between the user and the article, they can be also framed as interactions between the user and the tags. And there are multiple approaches. You can model an article as a bag of entities, for example, or you can rank the entities based on their importance. And there's a big shout out to an excellent library from Paco, Nathan was in the chat on, called TextRank, where it will give you the importance of an entity in a graph, and that can give you a weight that you can use later in your sort of bag of entities representation of the article, some things like that. Essentially, you don't have to use NER for Rexis, but in a lot of use cases, it's very useful.
Okay. The next one is, how do you deal with imprecisions with surrounding tokens in annotated spans, i.e., when annotators highlight as team Real Madrid move in hints Real Madrid move, especially when a superset of the true span tends to be selected?
So some of those imprecisions, you will have to deal with them and just keep them. But an easy way to augment the precision there is to use like the dictionary, like rule-based matching. If you have like a list of synonyms of your entities, and your model has given you a list of candidate spans, right? And your span is like Real Madrid move, but in your dictionary of when you perform what's called an entity linking step, in your list of entities, you just have Real Madrid. Then you can still keep the candidate span from your model, Real Madrid move, but then you just, at the end of the entity linking step, you just keep Real Madrid because that's what was present in your dictionary or in your knowledge graph or in whatever you're using there. That's how I would approach this. The candidate spans will never be perfect, and also depending on your categories, like for example this transfer one that I showed, it's very subjective as well, and it can depend on tone and things like that. Or from 1 month to another, you might decide that in your newsroom suddenly a transfer is not defined the same, and then your model, you have to retrain the model, relabel the dataset and retrain the model, like things like that. So it's definitely, it's not a perfect label, let's say.
Do you know of any interesting models for span classification that can predict overlapping spans?
Yes, so I don't know by heart, but for nested NER, I think new NER does nested NER as well. The only thing is that like Gleaner and new NER, I think from the paper, do nested NER. I've not tried myself. And also the spacey wrapper around Gleaner, I don't think does supports like nested NER because it puts the entities in doc.ends instead of doc.spans. But maybe by going deeper in that implementation and like playing with the model, it's possible to do. I don't know. But otherwise, for just finding baselines for nested NER, I would just look at the two datasets that I've listed in my slide, like the Genia and the ACE 2005. And if you go to papers with code benchmark, and then you go to those datasets, you will see the best latest models, and probably you can find them on GitHub or Hugging Face, and then they will give you something to start with.
There is any research paper comparing NER with span classification and LLM approaches?
Yes, so in my slides, I always include a reference slide that I hide during the presentation, but that's there, and I've listed a few papers. I would suggest to just start there, like just start with those papers and check the introduction, the number, like the first part of the paper is always like one introduction and then or two related work, and those first two sections are what you're looking for because they will explain the prior art, and then either a paper like that or more a domain paper. I think there's one domain paper that I liked. I don't know if I included it here, but there's one domain paper, for example, on like comparing NER models for biomedical field. And there, in this kind of like domain paper, they do the survey of all the different NER models. And so they will look at SpanCat versus LLM versus CRF models. So just pick a domain you're interested in and find it on like Semantic Scholar or something. That would be my approach.
How can we use NER for test classification?
Okay, how can you? That's interesting. You could, I think the easiest way is to not do that. I think you could do text classification just with a model for text classification. But if you wanted, you could do an NER step that kind of encodes you could see an NER model just like an encoder, essentially, but except like a sentence embedding model will give you like 248 dimensions, whereas an NER model will give you maybe just, let's say I have 5 labels, it will give you a vector of just 5 dimensions, competition, team, player, and then I could encode my article with my NER model. Maybe I can count the frequency or just the presence, 1 and 0s, and then use that to do text classification and just learn like a small classifier on top of that. That's just what kind of pops in my mind, but I've never tried that actually. But that's the way you could, that's a little bit like I was saying, like the modeling an article as a bag of entities to do then recommendation systems. That's a little bit similar to what I just said. You can model your article as a bag of entities and then do text classification on it.
Okay. And the final question, which kind of prompt do you recommend to do NER with an LLM?
So certainly the spacey prompt. So if you go to the source code of spacey for the spacey NER v3 task, that prompt is very detailed and is very good. And it's also right there already implemented inside the spacey pipeline. I don't know if I can show you really quickly, but I had like for this talk, I had it prepared. I couldn't really show you, but this is how you make it work. So you need to instantiate a spacey config. You pass LLM component, you choose your LLM model. In my case, I'm running an LLM locally with Olama. I'm running Mistral locally, and then you specify the task called spacey NER v3. You need to pass the labels, and then you pass like the label descriptions, which is what the model will use in the prompt. And then you just assemble the config from that, and spacey will feed that into the prompt itself. And you can find the prompt somewhere. I'm not sure I'm gonna find it really as quickly like that, but it's there in the spacey source code, and it's you are an entity, you are an NER annotator, whatever, and it's using these descriptions here as almost like a zero-shot example. And on top of that, you can also do proper zero-shot, where inside that spacey config, you can pass a zero-shot file where you specified some JSON line records of labels, or 2-3 examples where you've labeled some entities, and then spacey will also put that into the prompt. So I would say don't just recreate your prompt from scratch, just have a look at what spacey is doing and just use spacey.
Okay, yeah, that was the last question. So Yeah, thank you so much again, Luis, for having for attending today's community meetup. It was a really good talk. And yeah, just to finish today's community meetup, we will have Natalia from Argilla making an announcement of the new Argilla SDK. So,
Thank you so much.
yeah, thank you. So if you are there.
Yes, can you hear me?
Yeah.
Okay. Thanks, Louis, for the presentation. It was really nice. This is just like a very short announcement. I will be quick. As some of we're currently working on a new refactored SDK. And the idea behind it is redesigning it with a focus on making it easier to learn and easier to use because the SDK for the feedback datasets was becoming a bit complex. So unfortunately, some of the code that Louis shared today would need to change with this new SDK, but hopefully not too much and for the best. This new SDK will be the SDK of Argilla 2.0, which is coming soon. And Ben will present more and talk a bit more about this in the upcoming community meetup. So stay tuned. So actually my announcement is more about inviting you to try it out. We just released an alpha version of this SDK, and we'd like to invite the community to give us some feedback about how it looks, how it feels. So we have an insiders program to gather feedback on this SDK. And just a few pointers of how it works in case you want to take a sneak peek at this SDK. So the idea is that you book a slot to speak to me and Ben. And once you book, you will receive all the information related to the new SDK and how to try it. And then it's important that you've played around a bit with it before we have that call so that we can chat a bit about how your experience was. And if you find any issues that seem urgent or that are blocking, like you can reach out to the team or open an issue in the repo. So to do this, you can go to our beta testing channel in the Slack community, and you will find there a link where you can book your slot to participate. And if you have any questions, you can always find me in our community as Natalia. I will just paste a couple of links to the beta testing channel and also to book a slot for the insiders program in the chat here, so you can have it. That's everything. Gabri, over to you.
Okay, so yeah, thank you so much for attending today's community meetup. And yeah, see you in the next one. We will soon upload the talk from Luis on YouTube, and we will share the resources with you. And yeah, that's all. So thank you. Bye.